sekarang saya nak touch a bit pasal contoh-contoh application di offshore ataupun di outside lah. So saya just nak tunjuk contoh dekat sini. Contoh yang pertama adalah level control. Okay. Level control ni macam saya cakap tadi, kita dah discuss pasal sensor. Sensor kita ada satu dekat sini. Okay. Lepas tu kita ada satu valve dekat sini. VL maksudnya vapor liquid, LL is a liquid liquid. Ini more detail lah, tapi yang saya nak explain dekat sini, level control ni memang kita perlukan. The reasonnya supaya kita tak nak lah orang pergi buka tutup benda ni manually kan. Kita nak make sure that the valve ni hanya open bila level ni dekat certain level. Contohnya bila level high, kita tak nak lah kita isi drum ni dengan air ataupun any hydrocarbon and menyebabkan dia berlimpah ruah. So basically the reason kenapa kita ada level control scheme ni, kita nak make sure that the level is maintained within the specific set point. Kita tak nak dia melimpah. Itu saja. Next, pasal pressure control. Okay, pressure control saya cakap tadi memang very critical. The reason dia, pressure control ni, kalau tengok dekat sini kan, sini kita panggil dia as a drum lah or the reactor. Okay. So bila kita ada this kind of a reactor, you have a pressure measurement here. Bila pressure dekat sini terlalu tinggi kan, and katakan kita tak ada apa-apa di sini and then kita biar the pressure tu naik. So what will happen? Pressure akan naik terlalu tinggi menyebabkan rupture or retak or pecah lah dia punya drum ni. So bila benda tu jadi, itu yang kita tak nak lah. So what this control scheme will do, pressure bila dia detect terlalu tinggi, PIC ni is a pressure controller lah. Dia akan baca reading PT ni. Dia akan bagi tahu dekat valve ni, buka lah sikit, release sikit the pressure ni so that kita boleh maintain pressure. So dia akan buka. So bila dia dah buka ni, pressure akan bawah drop. Bila dah drop, dia akan tutup balik. So itulah reason kenapa kita ada this kind of pressure control lah. Okay. Okay, ini adalah contoh pressure control untuk a different application. Cuba dekat sini dia punya different dia adalah pressure control ni. Dia akan release untuk the heat exchanger lah. Basically dekat sini ada satu line. So bila ada satu line ni, bila line ni dia detect the pressure is too high, so dia akan bagi tahu dekat this valve lah untuk open more lah, untuk reduce the output or the load lah. So this one is not a direct control, but it involve a secondary control. Okay. Okay, condenser. Condenser ni basically, if I can relate lah, our air conditioner, our car aircon, semua ada conditioner. Sorry, not conditioner, condenser. Okay, so condenser ni is actually is a method to make, to condense our process more lah. So how to do that is to reduce the temperature by introducing a coolant or anything lah. So basically you can see here proses ni kan, dia ada heat exchanger. Heat exchanger ni ada dua purpose lah, satu nak panaskan, satu nak sejukkan. So contohnya adalah nak menyejukkan lah, sebab kita nak condense dia punya proses tu. So basically dekat sini dia punya dia ada pressure transmitter ni. Dia akan control dia punya pressure lah to be low, and then at the same time dia akan make sure that the flow of the coolant through the heat exchanger ni akan flow through lah, to make sure that the pressure after the heat exchanger is maintained. Okay, so itu we call it as a condenser punya control. Okay, alright, untuk flow control. Okay, flow control. Our flow control ni basically kita pakai flow meter, memang kena ada lah, nama pun flow control kan. Lepas tu the location dia it can be kebanyakannya is located sebelum pump ataupun compressor lah. So basically this example nak want to tell you is that untuk type of flow control. Basically you can control the flow pakai valve, ataupun you boleh control flow pakai variable speed drive. Sorry, ni dah a bit technical, but you can search lah. I just give you an example lah. So dia punya different ni dekat sini, satu pakai valve. Valve ni maksudnya dia akan control lah output of the flow tu through the valve. Tapi kalau pakai variable speed ni, dia basically daripada input flow control ni masuk ke controller. Controller ni akan instruct terus ke motor. Motor yang pakai VSD or VFD, variable frequency drive ataupun variable speed drive, dia is a intelligent motor. So motor-motor jenis macam ni, dia boleh control dia punya speed tu automatically based on the current, based on the input of the controller. Dia tak perlu valve dah pun. So that's the difference between these two flow control scheme lah. Kalau you want to find in apa nak search for more detail lah. Saya pernah nampak kedua-duanya. Sekarang ni yang belah kanan ni pun more and more being used because it is quite reliable. It's just that the cost to install this is very expensive one lah compared to this one. Kalau belah kiri ni motor dia motor bodoh je, dia jalan je. Dia jalan, dia tak boleh nak control dia punya output pun. Dia jalan je, lepas tu valve ni yang akan control dia punya flow. Tapi untuk belah kanan ni, motor tu akan control dia punya load sendiri based on the input ataupun daripada controller ni sendiri. So tak perlukan valve lah dekat situ. Itu adalah the difference between these two. Okay. Alright. So untuk punya pump, reciprocating punya pump, okay, ataupun ada positive displacement punya device. So dekat sini kompresor-kompresor macam ni kan, dia kita katakan dia typically bagi a constant flow rate lah. So basically macam pump-pump macam ni kan, dia is either you want to increase your temperature, your pressure. Biasanya you want to increase your pressure lah. So basically kat sini you can tengok on the flow scheme from the left to the right. So from the left ni dia akan masuk kita punya kompresor. Lepas tu dia ada return line kan. Return line ni macam minimum flow lah, ataupun dia macam spill back, or we call it as a minimum. Sebabnya bila kita mula-mula kita run kompresor ni, kadang-kadang kita tak boleh nak dapat dia punya flow tu buka sebab mungkin dia punya line terlalu panjang. So what we do actually, kita install this line untuk return ni untuk make sure that ada recycle line. Bila ada recycle line ni, kompresor dia ada flow kan, baru dia boleh work properly lah. So the worst case that you don't want from this type of scheme, whereby you start your pump or your compressor tapi you tak ada flow masuk. So bila tak ada flow masuk, that will be a major problem to the machine lah. Machine tu basically dia compress something kan, dia tak ada something, there will be a catastrophic punya issue lah. Okay, that's why you see the line here, and then the scheme here is to control the flow, and this flow is detect a low flow. What it will does, it will try to open this flow to make sure that the compressor tu ada at least a recycle flow untuk maintain dia punya functionality. Sebab bila tak ada flow ni, dia akan vibrate kan, shaking kan. Bila shaking tu dia akan menyebabkan kompresor rosak. Okay. This is for vaporizer. So vaporizer ni basically kita nak prevent any liquid liquid accumulation lah. Kita nak vaporize our product lah. So when we have a feed from the left here, okay, feed ni masuk, and then bila feed ni masuk ke dalam this drum, kita at the same time kita nak the vapor going out, and then at the same time how do we want to achieve the vapor going out ni, kita kena introduce heat inside the system. How to do that? We introduce a steam. Okay, so when we introduce a steam dalam this, kan, so basically this one pun bila kita introduce steam, at the same time kita pun tak nak ada liquid ni flooded lah dalam this drum. So that's why you can see here dekat this scheme, right, you can see that the condensate will go down at the bottom, and at the same time you have a level control here to open and close your valve lah. Bila liquid terlalu tinggi, this valve will shut off lah. So basically kita tak nak avoid any liquid going to the vapor punya line. Sebab vapor punya line ni kita pun tak nak contaminate dia dengan liquid. Okay. Okay. Yep. Yeah. This one is a bit simple. Temperature control. Temperature control ni is you have heat exchanger also. Ada proses and then you ada hot or cool utility lah. Kita boleh pakai seawater boleh, kita boleh pakai air. So many things that we can use. So bila kita ada heat exchanger, what we will do, we will just control the temperature of the product lah in the end of the day. Alright, the question. Okay. Admin, saya jawab soalan dulu . Soalan dia adalah how can a graduate be an instrument engineer, ambil EE, Electrical and Electronics. Lepas tu boleh ambil major control system ataupun instrumentation and control as your major lah. Saya graduate dari UTP for your information. UTP Malaysia lah, bukan overseas . Okay. Alright, let's go to the next one. Okay. Temperature control. Temperature control untuk air cooler. So ni air cooler ni pun is something not really common. I mean in our life lah. Tapi in offshore ke, this is a very common one. It's just a fan here. Fan ni berpusing . Dia macam fan biasa, fan kat rumah tu. Dia macam berpusing. Lepas tu dia ada contohnya bila kita proses kita punya gas jadi terlalu panas kan. Kita nak turunkan temperature dia, itu je lah macam tu kita buat. Kita ambil air daripada atas masuk ke bawah. So fan ni akan sejukkan, dia akan masuk dalam heat exchanger. So heat exchanger, fan ni dia akan blow lah. So basically wap-wap panas semua akan naik ke atas. And then yang keluar ni adalah produk yang lebih sejuk. So ini adalah air coolers lah. Okay. Alright. Saya sebut touch sikit pasal reaktor. Reaktor ni I think extra sebab reaktor banyak offshore pakai unless kalau newer floating LNG punya produk. Alright, sejak soalan dulu . Instrument technician lebih kurang sama ke dengan instrument engineer? Instrument technician tak sama dengan instrument engineer. Perbezaan yang betul-betul different between instrument technician dengan instrument engineer. Instrument technician ni dia banyak execute kerja dekat field. Sebagai contoh, tadi kita tengok thermocouple lah, contoh thermocouple atau valve. Yang repair valve tu technician. Tapi engineer ni kita yang bagi plan. Kita plan, maksudnya kita yang buat strategi. Contohnya bila rosak ni nak repair apa. And then kita yang buat strategi, contohnya valve ni bila kita pasang, macam mana kita nak install dia, macam mana kita nak design dia, macam mana kita nak maintain dia in the longer run. So basically the brain is engineer, the execution is the technician. Alright. Okay. Soalan from Anan, Ryan. So where does this control are usually located? Yang I share in the past macam contohnya apa tu just now flow control, level control, ke semua tempat oil and gas production ada pakai. Even di offshore pun ada pakai. Yeah. Siti Hajar ada soalan ke? Okay, so continue back to the question just now. This kind of control kebanyakannya mostly installed at many places lah. Alright. Okay, so for reactor control, this is a bit special because reactor control ni mostly dekat downstream application. Tapi since right now kita ada floating LNG, kalau you guys nak Google lah FLNG kan. FLNG tu actually upstream juga. So basically FLNG ni is a plant yang dulu located dekat darat, dibawa pergi ke tengah laut. So basically some of the equipment dekat darat di downstream pun dah di laut sekarang. Saya masukkan juga reactor control. Sebab reactor control ni is very very niche. Okay, so prevent children, later I answer your question. I explain this reactor control first. Okay, so untuk this reactor control, what it does, it basically kita nak cuba mixkan multiple product dalam reactor untuk dapatkan kita punya output lah. Sebagai contoh, kita nak buat chemical ataupun kita nak buat some product lah. Some product yang memang bukan daripada raw material. Tapi raw material masuk reactor dulu. Raw material contohnya saya bagi contoh chemical A atau chemical B lah masuk ke reaktor, and then kita ada reactant lah untuk react lah. So basically bila masuk reaktor ni temperature akan naik lah. So bila temperature ni akan naik, dia ada control scheme dia. At the same time kita can control the pressure, sebab bila you ada high temperature, you akan ada high pressure. At the same time your level of the inventory pun akan berubah kan. So basically that's why we need a proper reactor control. And then this reactor control is very critical sebab reactor ni is the heart of the plant lah, or the heart of the unit. Without the reactor, you won't get product or you get rubbish actually. So basically kalau you tak boleh control your reactor, your product is just a rubbish lah. So that's why we need this proper punya control. And then this is a typical setup of the reactor. Reactor ni is a bit complicated, but don't worry. Like I said lah, dia ada feed A and feed B. Dia ada dua campuran masuk. Lepas tu kita nak produk dia keluar dekat bawah ni kan. So basically the feed A and feed B ni need to be controlled at the specific flow rate yang kita nak. Maksudnya when we want to develop this product, we need to make sure that the product is within the tolerance or the specification by the kita punya company lah kan. So basically these two product will go in and then at the same time you will have a coolant to lower down the temperature. Yang atas ni when you have a high pressure, it will vent to the common header lah kalau ada high pressure. In the end of the day you want the product di bawah ni. So the product pun will be tied to the level control because you don't want to actually have a high level of inventory, because nanti bila ada high level liquid carry over ke sini, so kita tak nak lah. And then ada liquid pun backflow balik ke feed A dan feed B, nanti contaminated pula kan. So that's the reason why we have this reactor control. Okay, so question to prevent children, is this related to equipment engineer? Yes, you are right. Contohnya compressor, machine, the static or the vessel itself, it is related to equipment engineer. Tetapi for instrument engineer, sebab our discipline, we own instrumentation, but at the same time kita pun kena tahu process a little bit. So that's why eventually instrument engineer kita tahu sikit-sikit lah, like motor, like heat exchanger, like all these equipment. That's why when I talk, I macam boleh relate a few other things lah. So it's not really about instrumentation, but to understanding of the overall process and also the equipment is needed to become a proper instrument engineer.